Okay guys, I'm going to start from problem number 39. 1639. Okay, why I'm selecting this? Because I think some of the other problems are straightforward if you know the formula. 1. 2. The first problem is pretty much a free body diagram. And once you figure the free body diagram, you should be able to get it without a problem. Okay? However, this is kind of different. And I think this is very important to all of you. And I believe that you really need to know how to kind of simplify circuits and get values from it. Okay? So, let's draw our circuit first. So we have a collection of capacitors. I have a battery right here, 24.0 volts. Okay, I have a capacitor C1, and then I have a capacitor C2, a capacitor C3, a capacitor C4. Values. What's C1? Let's look at our books. Find the problem 39. 1 microfarad. Microfarad. Okay. Units are farad for capacity. C2. 5 microfarads. C3. Can't hear it. 8. There you go. C4, 4 microfarads. So let's try to kind of put a couple of other things right here for our convenience. I'm going to mark this point A, mark this point B, mark this point C. And also I want to say a couple of things here. Let's say this is L, this is M. It's important to have them for my discussion, right? First off, we need to find what components are serially attached, what components are parallelly attached into the circuit, right? So, how do we figure that out? How do we figure whether these two are parallel, these two are series? Anybody knows how to do this? How do you find two components of a circuit, whether they are parallel or series? Litmus test.
I can do it, but I can't explain how.
Simple way to do that would be to look at the current. If the current gets divided as it goes through the two components, then you have a parallel circuit. If the same current flows through both components or any number of components, then they are in series. Okay? Now let's look at this. So the current starts from here and has to come back to the circuit. It comes down to here. And as it comes to point L right here, it has two directions that it can go. It can go to the left can go to the right. So in other words, the current gets split, divided. So that basically means these two guys are in parallel to each other. Okay? Now, obviously, these two are also, fill in the blanks, parallel. So what about this collection and this collection? Series. Because if you look at the current after getting split at this point, they come together at this point. So it's the same current. And then it comes back to this guy, splits right here, not to the same components, maybe different, but at the end they come together at this point and comes down. So if you look at the current that's going in, goes through this part, collection of these two parts, collection of these two parts, exactly the same current that flows through here. Right? As a collection, independently it splits at this point, therefore they are parallel to each other, Okay? Having established that, let's try to solve this. First off, what are our formulas for capacitors? We know about the resistors, that we will look at that next week in the lab. I think in the class you have already done that. Have you guys done the series of parallel circuits? Have you guys done the resistance, how to add the resistors? Okay, good. There you go. So for the capacitors, in series, this is going to be what? Total capacitor is going to be a sum of in series, in parallel, let's make sure we know this before we start. Okay? Guys, if you cannot see this, you are most welcome to sit or stand there and look at it. If you can see it, it's fine. Okay? Just to let you know. And any time, just come here and look at it. It's okay. I'm going to erase this, guys, because I need the space. Okay? I just want to make sure that we are all on the same page before we start going further. Otherwise, we are in trouble. Okay, so now we have to start simplifying this. First off, I need to combine these two as a collection, and then I will also at the same time combine these two as a collection. Okay? So what do I get? I'm going to replace those two with a single capacitor, and I'm going to replace the other two with a single capacitor. We will do it in two steps. The next step would be to add these two and replace them with a single capacitor. Okay? So we are going step by step. So we look at these two. They are in parallel. Therefore, the capacitance here is going to be, what is it? 6 microfarads. Direct addition. Parallel. What about this? Let's put this as L and A. What is it? 12? Yes, absolutely. You could have your niece around here to do the sums, right? So easy. Why did Dr. G ask these questions, right? Okay. So, how do we do this next? Reciprocal. So let's do this. Let's do our capacitor circuit again. One last time. And then this is my positive. This is my positive. So now this is going to be a little bit different. This is going to be 1 over C, 1 over 6 plus 1 over 12. Okay, I'm not going to worry about the units at this point, because once I take the reciprocal, I should get the same units as long as I don't do anything funny, right? I'm going to keep my units as they are. I'm not changing any of the decimal place or anything right here. So, common denominator is 12. You can also do it in your calculator, but let's have some fun, right? So, 2, 1, right? So that gives you 3, 12, 3, 4, right? That basically tells me my C is going to be what? 4 microfarads. Okay.